Here we are looking at polynomials that have x-intercepts that have a multiplicity of 3. So let's go ahead and get started. We're going to look at multiplicity 1 and 2 again. So if I was to start with something simple like x minus 2, you can actually see the formation of a single root. So x plus 4, let's start there. And you can see that the single root is one in which the x-intercept of the graph is just curving through the x-axis in such a slight way that it's just following its normal pattern. But the minute I square it, if you remember back to that, if the minute I square it, the difference is we create that parabolic form. So if you look over at the x-intercept of 2, we now have a double or second multiplicity of 2, but over here on the left, we have a multiplicity of 1. It's still just going straight through. And of course, we can continue to change that. We can say, okay, well, there's a multiplicity of 2. Now we have both of them as a multiplicity of 2. And you can tell that because they are parabolic in nature. However, what happens when we have a multiplicity of 3? So let's just switch some things up and check it out. I'm going to go back to these squareds. I'm going to take them off. And what I want to do is we're going to go from a single root or a multiplicity of 1, and we're going to work our way up to the triple root. Now, nice and easy to do this. Let's start by taking the x minus 2 and squaring it. Okay, and we see that parabolic form show up. But this time, let's make it a cube, and boom! Notice what happens over here on the 2. It changes. It has a cubic formation. It does this little swerve and dance thing out here, the cubic formation, and that's what's ending up happening over here. This is still having a multiplicity of 1. Well, does anything else change? Let's put a squared on that 4. No, you can see it changes this to have a multiplicity 2 and brings back that parabolic formation. But over here on the left, the only thing that really changes is just how quick it occurs. But other than that, it still creates, it still holds on to that cubic formation. Well, does it still show up if I have a cubic formation over here? Check it out. Boom, it does. Notice what happens. Still cubic formation, but now it's on both of them. And we can determine that it's a cubic formation just by that nice swerve that is going through there. And that tells us that those roots count 3 times. So let's go ahead and do a quick example. And we can start solving some problems in just a second. So let's go here. We're going to do that. The first thing that we are going to do to identify it is we're going to identify roots as singles, doubles, or triples, or multiplicity 1, 2, or 3, depending on what and how we communicate that. So if I look at x minus 5, or that intercept of negative 5, I'm going to write this factor as x plus 5 cubed because it counts 3 times. I'm going to write this one, check it, it's parabolic in nature. So I'm going to write this one as x minus 2, and I'm going to square it because it's got that parabola look to it. And then I'm going to go ahead and find the y-intercept. I use a y-intercept because it is the easiest, which is 0, 50. And let's go ahead and start by saying y equals to a, and then we use that 0, 50. And we're going to start solving away. So let's do that. 50 goes in here, equals to a, 0 plus 5. Anytime we see a x, we're going to put a 0 value in there. And then we just keep working. So 50 equals to a. We got 5 to the 3rd power, 0 plus 5. 0, 5 cubed is 125 times 0 times negative 2 squared, which is going to be 4. And then once we have that, we are going to multiply 125 times 4, which is going to be 600. So 50 equals a times, 500. Okay, and then we're going to divide by 500. okay? And A should come out, if you're using Desmos, you can do that, should be 0.1. Now, let's go ahead and verify it. We're gonna change the color of the graph just to verify it. And I'm just type it in, okay? So let's call it f of x equals to 0.1, x plus 5, and that is cubed, okay? And then I'm gonna write x minus 2, but we are gonna square it. And check it out, boom, that graph lights up, it changes colors. We are in great shape. We did this 100% correct.